those are the ones that are on your problem set, so I'm not going to go through those. That would be silly, right? Okay. 58 and 49 are marked as things that I want to go through. No one asked about 51, and I was kind of surprised by that. Is there anybody that would like me to go through question 51 from the homework? Yes? Okay. I kind of thought maybe. Here's my plan. I'm going to go through 51. We actually did go through 49 already. That was the pelican problem. I am going to throw out question 58. You do not have to do question 58. I don't want you to worry about it. I don't want you to stress about it. I don't want you to do it. I mean, if you already did it, good for you. You're a rock star. You win my, love and admiration for the next 4 days. But, I know, right? That's pretty good. This is what I want to do in the next 15 minutes. I want to get through number 51. And then I want to do one other question that's not actually a homework question. It's an example question that will help you to do the problem set questions. Does that sound okay? So that's what I would like to do now. We're going to start with number 51. So go ahead and open up your book that you now have in front of you after that 90-second jaunt. Let's take a look on page 73 at question number 51. I'm not going to have time to go through the whole thing, but I do want you to look at it. 51 says, a speeder passes a parked police car at 30 meters per second. The police car starts from rest with a uniform acceleration of 2.44 meters per second squared. Now, before we even get into how to solve this problem, some of you may drive already, but probably most of you don't drive by yourself. I want to make it very clear. If you happen to be going above a speed limit and you pass a police car and that police car turns on its lights and starts to follow you, you don't just continue at the same speed as you were going before, okay? Which is what this story is, right? Don't do that. That is not a recommended approach to driving. But if you put your brake on, then it makes the physics a little harder. So for this question, we are assuming that the speeder is not good. Well, they're not speeding up either. They're just going at a constant speed. Not a good plan, okay? And then they shouldn't be driving. How many objects do we have in this problem? 2. So how many lists of givens do we want? 2. I want you to right now take a look and then raise your hand if you can tell me a given to write down. Everybody should have their hand up in just a moment. Raise your hand if you can tell me something that's on the givens list. Everybody should be able to tell me something on the givens list. Cindy, what can you tell me that's on the givens list? 30 meters per second. And where does that go? Who is moving that fast? The speeder is moving at 30 meters per second. And what is that a measure of? Yeah. So I'm going to say the velocity of the speeder is 30 meters per second. Fantastic. What else can you tell me? Everybody should have their hands up because you can find other numbers in that problem, right? Yes. Yes, I can. Abdul, what else you got?
Police car starts from rest and uniformly accelerates at 2.44 meters per second squared.
Look at that overachiever telling me more than one thing. Jeez. Yeah, the initial velocity for the police car was, what did you say again, no?
0.
0. And what else did you tell me?
The police car accelerates at 2.44 meters per second squared.
Is that okay with everybody? More stuff. Raise your hands if you can tell me something else. Oh my goodness. Yeah? John, you don't seem convinced there. Everett, what you got?
You don't know what the time is?
You don't know what the time is, so that's a question mark, right? In fact, that's what they want to know, right? How much time passes before the speeder is overtaken by the police car? What else?
I have a question. The speeder, his velocity, is that the initial or is it just velocity?
Well, that was what I was about to ask you. Huh. Does the speeder's velocity change?
No.
No, because they're a bad driver, right? So if the speeder's velocity doesn't change,
0.
what is the acceleration? 0. Is that okay with everybody? Okay, that's a big deal. Bless you. We want to know how long it's going to take for the police car to overtake the speeder. What does that mean, to overtake? To what? Somebody said something. To pass them, right? So it's like a situation like this. So here's the speeder, and here's the police car. Okay? And the police car starts at rest, and they pass this place, and then sometime later, they're going to pass another line, and the speeder is still moving at the same speed. What about the police car? Is the police car moving at the same speed that it was at before? No. How does its speed compare with the speed of the speeder? What do you think?
The same or faster?
It is the same or faster. Which one?
Faster.
Why do you say faster?
Because it's accelerating and the car's not, but the speeder's not.
Yeah. The speeder's not accelerating. If this starts off at 0, if it just got to the same speed, it's just going to be like trailing behind at some place, right? And then they're never going to get, and then the problem is silly. So the police car's got to be going, woo, really fast in order to catch up. Here's my question for you. Have you seen this? Not I'm saying like out in real life. Have you seen this phenomenon? Not even outside. Have you seen this phenomenon in this room? When did you see it? The ball in car lab. This is the same question. The ball is the what? The police officer, right? And the car that's moving at a constant speed is the speeder. Does that make sense? It's the same problem. It's exactly the same thing. Okay, so we want to know the time. And you're telling me that they traveled the same distance. So that means that delta x for the speeder equals delta x for the police car. Yes? Is that okay? How you feeling? Is that all right? Yes? Yes? All right. You need your equation sheets out. Let's take a look here. I know stuff about displacement. I know stuff about initial velocity. I know stuff about acceleration. I know stuff about time. Or I want to know about time. Is there an equation that has those 4 things in it? Do you see it? Take a look. Compare with your neighbor. See if you can identify it. And compare with your neighbor and see if they agree with you.
That one best friend.
I told ya. What did you say?
The one best friend that person you don't know.
You love it.
Yeah, you love
Right?
it, but you don't at the same time.
I love it. Skylar, did you guys pick an equation?
So we got those.
Third one. Was that the big, long, scary one? Yeah. All right. Let me grab your attention. Did y'all pick the big, long, scary one? The one that you're going to feel like it's not even big, long, and scary soon because you're going to use it all the time. Oh, wait, you used it earlier today, right? And now we're going to use it again. It just keeps going. So we have this nice, cute little equation. Delta x equals delta x. We're going to make it big and ugly. You ready?
Yeah.
Yay! All right, here we go. So I'm going to take this nice little happy equation, and I'm going to make it gross. Are you excited? Yes is the right answer to that question. All right, so delta x, instead of writing delta x, I'm going to write VI for the speeder times time plus 1/2 the acceleration for the speeder times time squared. Right, so this thing and this thing are equal. Is that okay? They also equal that, so I'm going to go ahead and put the stuff for the police car next. Equals VI for the police car times time plus 1/2 the acceleration for the police car times time squared. Wow, that's pretty. But we can make it pretty fast. How do we make things prettier? What do we look for? What do we try to find? Zeros, right? Take a look with your partner and see how many things you can get rid of and make go to zero. Have a conversation at your table. Real quick. Go, go, go.
0.
All right, I want to regroup with you. Come back. Emma, what's one thing you got rid of? It gets rid of so much, doesn't it? Like this whole thing goes away. Does that make sense? Sweet. All right. All right. And Rosemary, what else did you guys get rid of?
You can get rid of the velocity of the police car.
Yeah. So that whole thing goes away. And now that nasty equation that Ms. Carpeling just made you write down is a little bit prettier. So VIS times T equals 1/2 A sub P T squared. Is everybody okay with like the notation there? It's not pretty, but it's a whole lot prettier than the thing above it. Would you agree? Yeah? What are we trying to solve for? T. So we want to get all the T's on one side, get everything else somewhere else. Any recommendations as to what we should do? Go, May. Maya, sorry.
Divide both sides by 1/2 A, and then divide both sides by delta T.
Okay. Did you guys all catch that? Okay. Divide both sides by 1/2 A. So that's going to get rid of that mess. And then she's going to divide both sides by T. Now, I'm okay with that. If you are a super picky matho person, then you might get upset by the fact that we're dividing by T, because technically, you're losing a solution. What does that mean? It means that we're trying to find the time that they're lined up, and they're lined up at the beginning at 0, right? But whatever. We don't really care about that. So I just want to make sure I say that so that the math people don't get cranky at me. I'm going to go ahead and divide by T because it seems like a good thing to me. So those T's are going to cancel. And I'm left over here with VI for the speeder divided by 1/2 A of the police car is equal to T. And that's kind of nice. Okay? Then you can plug it in. No problem. Part B of that question says, how far does the speeder get? What are we looking for the how far? The distance or displacement? So you can just use this equation here. Is that okay? That part's pretty easy. Just plug in that time and then you're good. Okay. Are we okay there? So now you know how to do that problem? This is what I'd like to do. We don't have time to do that last problem that I promised you, so we're going to do it next time. Let me tell you my plan for next time. Listen up. Don't pack up yet, because if you do, you're going to be a sad kid tomorrow or next time. Okay? On Monday, I told you we were going to take the test. We need to do one more problem. So on Thursday, we are going to work one problem. And I will answer any other questions that you have. On Thursday, you're going to turn in your reaction time lab. part you want to make sure you're paying attention to. On Thursday, we are going to start chapter 3. I would strongly recommend that by Thursday you read sections 3.1 and 3.2. I would strongly recommend that you read sections 3.1 and 3.2 before you come in on Thursday. Okay? Please make sure that all the textbooks get put away before you go. If you borrowed a calculator, make sure that that gets put away. Once that all happens, have a wonderful day.